He and I ended up.
Yeah, it was extra tournament.
Wait, that thing, could you
Yeah.
get that thing?
We were different.
No, he told me how like Penn. So then I switched to
I'm gonna start running for all this.
Make me your radio and turn me up when you feel low. This melody was meant for you. So sing along to my stereo.
Class heroes, baby. If I was just another dusty record on the shelf, would you blow me off completely like everybody else? If I asked you to stretch my back, could you manage that? Like, yeah, Travis, I can handle that. Furthermore, I apologize for any skipping tracks. This is the last one, made me left a couple cracks. I used to, now I'm over that. Cause all the grudges of the love is ancient artifacts. If I could only find a note to make you understand, I sing it softly in your ear and grab you by the hands. Keep it stuck inside your head like your favorite tune. And an old school 50-pound robot. Would you hold me on your shoulder wherever you walk? Would you turn my volume up in front of the cops and crank it higher every time they told you to stop? And all I ask is that you don't get mad at me when you have to purchase Mad D batteries. Appreciate every mixtape your friends make. You never know, we come and go like on the interstate. I think I finally found a note to make you understand. If you can hit it, sing along and take me by the hands. Keep me stuck inside your head like your favorite tune. You know my heart's stereo, the only place for you. Heart's a stereo, it beats for you, so listen close. My thoughts in every note. Make me your radio, turn me up when you feel low. This melody was meant for you, so sing along to my stereo. Because good music can be so hard to find. I'll take your hand and hold it closer to mine. Yeah. Our love is never mine and changing my heart's a stereo.
Testing. Can everyone hear me? All right, good afternoon. It's so wonderful to have everyone join us this afternoon. My name is Rachel, the operations lead for Penn Electric Racing. It is my great pleasure to welcome all of you to the unveiling of our newest race car, REV9. Over the past few months, the team worked extremely hard in designing and building the car. The countless hours in the PER workshop and machine shop, the earlier alarms at 6:30 that not only wake you up, but also your roommates, and all types of engineering work that you could possibly imagine are what make this car possible. Today, we're all very excited to be here to finally present REV9 to all of you. But before we do that in just a moment, I would like to introduce a little bit more about the team and the work we do. Penn Electric Racing is a completely student-run club where we design and build a race car from scratch every year. The team is split into 4 different sub-teams: mechanical, electrical hardware, electrical software, and operations. The mechanical team is further split into 7 different subsystems: aerodynamics, battery pack, chassis, driver interface, suspension, vehicle dynamics, and powertrain. We participate in the Formula FSAE competition every year in June, which is a global competition with a history of more than 40 years, where we compete in the North America Electric Division. We're very proud to share that REV8, the car that we built last year, placed 4th in skid pad and 6th in autocross. The current car that you see right here is our 10th generation of race car, REV9, which features quite a lot of innovations. The sub-team leads will soon share more about the details after we unveil the car. This season has been challenging, yet the team came together and persevered. We're very, very proud to finally be here and present REV9 to everyone. But before we do that in just a second, I would like to ask everyone to please remain where you're standing right now after we unveil the car. The sub-team leads, as I just said, they will share more about the technical details about REV9. So, without further ado, on behalf of the team, I would like to present REV9.
Good shit, Derek.
Look at all the sponsors on the spoiler.
Hi everyone, I'm Lauren.
And I'm Rohan. As the mechanical leads, we are incredibly excited to show you what we've built, as well as share what makes REV9 our greatest car till date. However, I'd like to first thank the MEME Educational Labs, as well as the MEME Technical Pro staff, for all their help and guidance this year, especially Jason, Ari, Pete, Peter, Bruno, Devin. All of you guys are incredibly crucial to getting our car built every year, and as your students, we're incredibly proud to show you what we built.
This year, the mechanical team focused on 2 overarching goals. The first was innovating on our powertrain system, which includes our battery pack, transmission, and unsprung assembly. Together, these components can achieve up to 80 kilowatts of power, which means that REV9 will hit a top speed of 100 miles an hour. Our second goal was reducing our car's weight to under 200 kilograms. This required significant design, analysis, and validation as we cut weight significantly from every area. I am proud to say that these efforts were ultimately fruitful, leading to our car weighing in at just under 190 kilograms.
REV9 features an all-new motor that is lighter, more compact, and perfectly integrates with our custom planetary gearbox that our powertrain team designed and built this year. This is perhaps the most ambitious task the team has undertaken in many years. Furthermore, our limited slip differential, which controls the relative wheel speeds of our tires, is now outside of the chassis, improving the adjustability and accessibility of our car for the various dynamic events at competition.
Our suspension team also made quite a few exciting advancements this year, cutting weight on an already optimized subsystem. For the first time in our team's history, we have made critical suspension components such as pull rods and tie rods out of carbon fiber. These components are extremely lightweight and strong and have been proof loaded to up to 6,000 newtons, which is over half a ton of force. Further, our suspension features maximal tunability with our custom in-house machine titanium anti-roll bar blades. These components allow us to adjust the roll stiffness of our car with great precision so that we can tune on the track based on driver feedback.
Using custom computational fluid dynamic simulation, REV9 boasts a redesign of our side wings, as well as a refinement of our manufacturing processes, giving our car a sleek finish. Moreover, generating over 90 pounds of downforce, each of our wings sources a multi-element airfoil configuration that sources a genetic algorithm to simulate over 2,000 different test configurations and ultimately arrive at the most optimized setting.
Finally, this year we redesigned our battery pack with the goal of optimizing power and capacity per unit mass. This year's pack is 90 pounds, which is over 20% lighter than last year's pack. It also has a peak voltage of 600 volts achieved with 144 pouch cells in series. This is the highest voltage pack the team has ever made, allowing us to drastically improve our thermal efficiency. We also entirely revamped our battery's mounting scheme, allowing us to insert and remove it in under 5 minutes, saving us valuable time in the pit. The battery was designed for seamless integration with the BMS, or battery management system, in mind. I will now hand the mic over to Katie and Kenzo to speak a little bit more about the electrical innovations that make driving REV9 possible.
Hi everyone, I'm Kenzo.
And I'm Katie, and we are the electrical hardware leads. Our team is among one of the few FSAE teams that has a fully custom electrical system. This means that the team designs, reviews, and validates more than 30 custom printed circuit boards each year. Following our team goal of weight reduction, we are also excited to share that we were able to reduce our circuit board size by almost 40% this year. In addition, there are many other new and exciting projects that we have been working on, and we are super excited to share with you guys.
For REV9, we are transitioning from using an off-the-shelf controller to being one of the few teams with a custom motor controller. Our very own design allows us to deliver up to 80 kilowatts of power and make up to 2 million measurements per second. In addition, it is capable of switching at a frequency of 100,000 hertz, providing a smooth driving experience and high efficiency. Not only that, it is 70% lighter than last year's, weighing just under 4.5 pounds, and boasts a power density higher than many other controllers across published research.
With REV9 now featuring a battery pack that is almost 200 volts higher than REV8's, we have designed a battery management system that ensures that high voltage is safely powering our motors and that all 144 battery cells are operating under safe and healthy conditions. We're able to do this with the help of over 2,000 components and 19 separate circuit boards. In addition, we have also implemented a galvanically isolated shunt current sensor that allows us to monitor the current drawn from our battery more accurately. This measurement is then used to estimate our battery's state of charge, which helps us safely gauge how efficiently we can recharge our batteries through the use of regenerative braking.
The operation and tuning of our car is highly dependent on the numerous sensors present throughout our system. As a result, it is critical that we centralize all of these measurements to a single location. This is done through our new data acquisition and visualization board. No worries. Not only does it have a more powerful compute module, this board allows us to integrate even more sensors and faster data logging speeds. Another exciting addition is the implementation of 4G LTE communication. Just like your phone is always connected, we're now able to optimize and monitor our car from virtually anywhere.
Of course, the integration of all of these hardware components would not be made possible without the help of software. So now I'll be handing it off to Eric, who will be talking more about the software that controls our car.
Thanks, Katie. Thanks, Kenzo. My name is Eric, and I'm the electrical software lead. You guys just heard some of the amazing changes and new designs coming out of the mechanical and hardware sub-teams. This year, software has also been hard at work to design robust systems and code to help power the car and bring it to life. We are so excited to share with you guys some of the changes. In line with team's goals, we've worked on reducing the metaphorical weight of the car by refactoring some of the code base written in over 1 million lines of C++ code. With that, we'll be able to reduce time debugging and spend more time testing to reach our goal of 100 miles. But 100 miles of testing means 100 miles of data. But with the power of our new data board, we've optimized the pipeline to ensure quality testing results. All of that is sent in real time to the dashboard, to the driver, through our new UI, which shows a series of metrics including cell voltages, temperatures, wheel speeds, power estimates, run estimates, and high-quality GPS data, and more. That's all packaged together and sent in a file system that's lightweight and portable to our data servers that can be accessed through any device, anywhere over the internet. Moving deeper, our embedded code controls and handles all the communication between the printed circuit boards in the car. This year, we've made improvements to our battery management systems, which handle safety metrics for our new battery design. Our power distribution software, which diverts electricity all across the car, as well as our aforementioned data boards for speedy, efficient telemetry. We've also made updates to our powertrain code, which helps run the car, and implemented algorithms such as traction control to optimize the wheel speed to slip ratio and get an even faster acceleration time. The software team's also been helping out in developing the motor controller code for our new design alongside the hardware team. We have custom-built motor controller firmware that splits current into 3 phases, uses a hardware programmable chip to get sensor data at blazing fast speeds and process it, as well as other optimizations such as field weakening to get every bit of speed out of our motors. These are just some of the many changes we've made to the software of REV9, and we can't wait to see it in action at competition. And to highlight the group that gets us there, I'd like to hand it back off to Rachel to talk more about the operations team.
Thank you, Eric. Now it's back to me again to elaborate a little bit more on what operation does on a daily basis. The operation team is responsible for a wide range of things, including sponsor outreach, recruitment, managing internal and external logistic, marketing efforts, and preparing presentations for competition. This year, I would like to especially highlight the team sponsorship effort. The support of our sponsor plays an important role in shaping the car today and the pursuit of our student engineers. On behalf of the team, I would like to express my sincere gratitude to all of our sponsors for your tremendous support this season. Additionally, we would like to thank Penn Engineering for giving us this opportunity. Special thanks to Dr. Tertuliano, Dr. Jackson, the purchasing office, EOS, and all Mean Pro staff for your support throughout the season. We truly could not have done this without all of you. Penn Electric Racing is a unique club on campus, and it holds a special place in all our hearts. Not only we gain valuable hands-on experience, but the hard work and dedication that we put in truly bonded us, allowing us to develop lifelong friendships. I would also like to take this moment to especially thank our sub-team leads. The team would not have accomplished this without all of your time, commitment, and leadership. Last but not least, shout out to everyone on the team and the amazing rookie class. As we're coming close to the end of Unveiling, I would like to invite everyone to take a closer look at REV9. Before we do that in just a second, I would appreciate everyone's patience for the team to just take a quick team picture. All right. Thank you so much for coming, and we would like to have everyone to take a closer look at check out Rev9. However, we do kindly ask you to not touch any component of it. And thank you everyone who are tuning in on YouTube. Thank you so much for coming. Once again, we would like to see you again next year. Thank you.
Thanks for coming.